Welcome to the Chapter 4, Section 5 podcast. This is called Free Fall, How Fast? And the main concept with this section is going to be about the acceleration of an object in free fall is 10 meters per second squared, and this is a very important number for us to remember. Now let's set up a scenario. We're looking at a scenario where you have no air resistance, and the only force you have is gravity. And we call this situation free fall. The only thing that's influencing the object is gravitational force. We're going to be using this term a lot, and it's not to be confused with the parachuting term, which is usually what a parachutist uses to say the fall right before they open the parachute. And we're going to be talking about elapsed time, which is the time since the beginning of the motion, in this case, the fall. So during free fall, during each second of it, an object's speed increases by 10 meters every second. We call this the acceleration. And here's the time for it. So what this is saying is its change of speed is 10 meters per second every second. And so acceleration in free fall is 10 meters per second squared. So we're talking about units here. We're talking about change in speed in meters per second. We're talking about time intervals of seconds. So therefore the acceleration is going to be expressed as meters per second squared, which we've talked about in the last section. You can see once again the unit of time occurs twice, once for the unit of speed and again for the time interval during which speed changes. The letter we're going to use to represent this is g, because the acceleration word is due to gravity, so g stands for gravity. This is, once again, this is an acceleration and it's due to gravity, so the letter we use is g. And for the most part it's 10 meters per second almost over all the world, and the real true value is 9.8 meters per second squared, but for purposes of making the math simple, we're just going to use 10 meters per second squared. All the calculations are very simple. You just multiply by 10. Now the instantaneous speed of an object that's in free fall can be found by this equation. The velocity at any instant is equal to the acceleration due to gravity times the time it's been falling, the elapsed time. And that's pretty much the explanation right there. So let's put a speedometer on a rock to see how fast it's going. So each second the rock falls, its speed would increase by 10 meters per second. So this is what it would look like in a chart. If we release something at time 0, it's not going to have any speed. That's the moment we release it. Then after 1 second, the object's velocity will increase by 10 meters per second. After 2 seconds, another 10 meters per second, for a total of 20 meters per second, and so on down the line. The equation is the velocity will equal 10 times the time, the elapsed time it's been falling. Remember, 10 is g. So the average speed of an object that's been moving in a straight line with constant acceleration is the average of the initial speed and the final speed. Now we have that situation. We're dropping an object, it's free falling, it's got constant acceleration, it's moving in a straight line. So if you look at the average speed for an object in the first second, it would be the sum of the initial speed 0 and the final speed 10 meters per second, and divide by 2, which would be 5 meters per second. Now let's throw an object straight up, and this is it's actually very similar. It's going to move upward for a while, then what is it going to do? It's going to stop. At the highest point, the object is changing its direction to go from upward to downward, so its speed is going to be, at that point, 0 for just an instant. It's going to have no speed whatsoever as it turns around. And then it falls downward, but think about it. It's just as if the object was dropped from that spot where its velocity is 0. So it's just as if it's in free fall. So let's look at it even more detail. if you throw the object up, it's going to slow down from its initial upward velocity to 0 velocity. And we know it's accelerating because the velocity is changing. It's slowing down. So how much does the speed decrease each second? It decreases at the same rate. Same rate as it increases moving downward. It's at 10 meters per second each second, 10 meters per second squared. Now, the speed of an object at any point when it's going up and down is going to be the same whether the object is moving upward or downward. In other words, if when you throw a ball up into the air and then it comes back down, it's going to leave your hand. Let's say it leaves your hand at 2 meters per second. It's going to come down and hit your hand at the same elevation at 2 meters per second. This is something I always tell my soccer players. Think about how hard a goalie punts a ball. That ball is coming off the goalie's foot at a pretty fast speed. Then when it comes down and hits the player's head further down on the field, it's hitting their head at roughly the same speed that it leaves the goalie's foot. So now the speeds are the same, but the velocities are different because, one thing, direction. And this just talks about the acceleration. The speed of the velocity changes by 10 meters per second downward, because gravity is always going downward. So it doesn't matter whether whether the ball is going up or going down. The acceleration is always in the downward direction. So let's look at this. This guy right here releases the ball at 30 meters per second. When it goes up for 1 second, it's going to lose 10 meters per second. So it's going to be at 20 meters per second after 1 second of going up. After 2 seconds, it's going to lose 2 times 10 meters per second. So it's going to be 30 minus 20 is 10 meters per second. And then in that final second of rising, it's going to lose that last 10 meters per second of speed, and the speed is going to be 0. At this point, it's kind of that instant where it's not traveling at all. Now, on the trip down, it's just like dropping it. In the first second, it gains 10 meters per second. In the second second, it gains 10 meters per second for a total of 20. In the third second, it gains 10 meters per second, and now you notice it's at the same height as it was released, and it's at the same speed as it was released. And in this last second, it gains another 10 meters per second for a speed of 40 meters per second. You can see it went over a cliff, so it was able to continue on its trip and gain even more speed. So, let's do a little math right here. An object begins at 10 meters per second and ends at 20 meters per second. What is the average speed during the object during this 1 second interval? What is its acceleration? Well, to find the speed, you would take the initial velocity, the final velocity, add them together, and divide by 2, which would give you 10 meters per second. The acceleration during this trip is always going to be 10 meters per second because it's undergoing force due to gravity. Here's another one. What would the speedometer read on a falling rock be 4.5 seconds after it drops from rest? How about 8 seconds after it drops from rest? Well, remember, the equation for that is V equals G times T. So our velocity, all we would do is multiply 10 meters per second times t. So the two velocities would be 45 meters per second and 80 meters per second respectively. So what's the acceleration of an object in free fall? Acceleration of an object in free fall is 10 meters per second squared.